Hello, everyone. So we have another AMC 12 problem. So this was actually an interesting problem and also have a lot of like ways to solve. So this was like number 22 on 12A. So the question has like a circle, has a radius of 4, so which is this guy. And there is 6 rectangular plates, Matt, are placed on the table. So those rectangles are given, and each placemat has a width of 1 and the length is as x. So this is x, this is 1, this is x, 1, this is 1, this is x. And they are positioned so that each mat has 2 corners on the edge of the table, right? So like this way, those are the 2 like corners. And these corners are being the endpoints of the same side of the length x. Okay, so which is kind of given already. Refer that the mats are positioned so that inner corner each touch an inner corner of adjacent mat. So they are touching each other at these corners. What is the value of x? So since we are told there are 6 rectangular like mats, they are identical. So we are gonna say like we have like this side, this side, this side, this side, this side, this side, all are equal to, which is the sides are equal. That means the figure inside is regular hexagon, right? So then we can actually easily find the angle. So I'm gonna say this is gonna be like if I divide 360 by 6, so that will be 60. This is gonna be exterior angle of the hexagon, so which means interior one has to be 120. Or you can just use n minus 2 times 180. This is some of the interior angles of any polygon. And if you divide this by n, so you get the interior. So if you take n is 6, so 6 minus 2 will be 4. So for 180 times 6. So you can cancel the 6. That will be 30 times 4, which is 120. That will be interior. So again, this is exterior, this is interior. So you can use either way. But this is what we have. So all the interior are 120, and then we just need to relate the given number 1 and x as well as the radius of 4. So, this is a circle problem, and I always recommend to draw the radius, right, from the corner, like a center to a intersection. So I'll take this intersection. You can take any intersection because I need to relate those numbers. And if I want to take this one and I just need to maybe relate this to this side as well. So because that will be also good to have. But if I do this, right, if I connect this, that's radius. I get it. But how do I relate this? So which is why maybe it is good to connect this intersection to this one as well. So you will have a triangle, even though it looks like smaller figure. So let's say this is O, right? This is 1, and then this side is like 4. So because that's the radius. And this is the only side that we do not know. But we actually know the angle right here is 90. And then since this figure was like this angle was 120, and then we just draw this segment to bisect the 120, which will be 60 and 60. So there is a nice triangle over here. So let's go ahead and kind of make it a bit bigger so we can kind of see better. So that will be something like this. And it's good to kind of make it bigger when actually things are not easier to see. So I will go with this is 1 and this is 4. And then this is gonna be, we do not know yet, but we can just kind of say same as x, because if you connect this to this, so let me actually draw that as well. If you connect this to this, or maybe this one, so this triangle, isosceles, but it's not just isosceles, it's actually quite a triangle, because we know that if you connect this to all these corners, you will get 60, 60, 60, 60. There will be 660s in the center. And then we know this is going to be equal to this. So which is going to be isosceles. The triangle has a 60 right here. So these two has to be 60, which will make this is a quadratic triangle. So we need that this guy is also x. So which is actually nice because that's what we need. And we know that the angle in between is 90 plus 60, which is 150. So since this is like 12 problem, AMC 12 problem, so law of cosine is really useful in most cases. So I'm going to use log cosine first. So log cosine is just going to be, I'm going to use this side for L1. So that should be 4 squared, which is 16, equals the square sum of the other two sides. So the x squared plus 1 squared minus 2 times x times 1 times cosine 150. So again, if you don't remember the log cosine, it's something like this. Square of one side is equal to sum of the squares of the other two sides minus 2 times these two sides and times cosine of the angle that is opposite to this side. I'm going to name this as cosine A. So you can use this for any side, but this is the basic reminder for the log cosine. So I'm going to put it here. So, and then I just use that right here. And the rest just the Pythagorean. So, I mean, the quadratic formula, I would say. So that will be x squared. So, but the cosine 150 is one of the common angles that we should remember. So this is going to be a negative number because cosine in the second quadrant is negative, and then cosine 150 is √3/2. And if you don't remember this, you can just always draw a 30, 60, 90 triangle, and then or unit circle. So if you just draw a 30, 60, 90, for example, like this, because 150 corresponds to 30 degrees. So I'm going to say this is 60 and this is 30 degrees and this is going to be that. So we know this is x, 2x and x √3. And the 150 cosine 150 is equal to the negative, like cosine 30 is same as this one, but the negative version of this. So I will say when you, actually, maybe it's good to draw the unit circle just to kind of show the reasoning. So if you know the unit circle, it's going to be something like this. Okay, so the unit circle, so let's take this guy as my x-axis. So you will have this is 90 degrees, and then 150 will be somewhere right here. Okay, so then if I need to know, like this is 90, so if you just go all the way to the 150, so which means this is 60. So you need to know the x coordinates of this one, which is going to be our cosine value, right? Cosine like 150. So sine 150. So that's how we use the unit circle. And the cosine is the x coordinate. So if you drop a height right here, so you just need x coordinates. So if this is 1 as a unit circle, this is going to be 1/2, and then this is going to be √3/2. But that means the cosine of 150 is going to be √3/2, but that will be just negative. So because it's in the second quadrant, cosine is negative. So you can use this, or you can just use the cosine of 30 degrees, because cosine 150 has the same absolute value of the cosine 30, which is going to be this divided by this. But since this is negative, we should just choose √3 with negative. Okay, anyway, so we got the cosine 150. I mean, that is the case. So then you just have the answer like x squared plus 1 minus, but this is also minus, so this becomes 2 times √3/2, but there was x as well. So cancel this is equal to 16. So again, the rest just the quadratic formula. If I simplify this a bit, x squared, and then you got x times √3. So I will say √3 times x minus 16 is equal to 0. And if you just plug into a quadratic formula, so you are going to end up getting choice C. Okay, so that is one way to do this problem. So if you like to use the log cosine, so this is basically what we are going to have. Actually, this is not actually 16. This is 15 because there was 1 as well. So this has to be 15. Okay, so again, quadratic formula will give us the answer as C. But this is the log cosine approach. So if I don't want to use this one, if I actually look for another solution, because there is 30, 60, 90, there's like 100 degrees, 150 degrees, that's a good indicator that we can actually use the 30, 60, 90. So one of the ways we can do, we can just extend this segment in a way that we can drop the altitude from this corner, so to that extension, so we can make a right triangle. So the reason why I'm doing this way, because the 150 will make 30 degrees outside, so we can have a 30, 60, 90 triangle. So 30 degree is equal to this side, opposite to this side, so which has to be half of this number. So that will be x over 2. And then this side will be x over 2 times root 3. And now we have a Pythagorean, so if you just use x over 2 squared plus x root 3 over 2 plus 1 to the second power. This is equal to 16. And then if you just solve this equation, so that will also give us the same result, so which is choice C as well. But maybe I can show how to get it, but let's actually try that as well. So if you square this, you will get x to the 4, x squared over 4 plus, if I square this one, the square of this guy will be 3x squared over 4 plus the product of these two will be x root 3 over 2. But if you double that, if I square a binomial, so you get x root 3, and then square of the second term will be just 1, and that's equal to 16. Okay, so if you combine these, you got 4x squared over 4, which is just x squared, and then you got x root 3. And then this is 1, this is 16, subtract 16 from both sides, so you will end up getting the same equation. Again, this is the same equation that we have right here, so if you just use the quadratic formula, so you got the same result. So there is another way, actually, I'm gonna do this problem, which is probably my last way to start. So let's try that as well. So what I will try, we know the angles. The angle right here was like 120. These are all 120, but there's a lot of nice symmetry going on. So since we know, if I take, let's say, I don't know, this line, okay, and try to draw the diameter, that has to go through right in the middle. So, or if I want to draw like the different way, so I can make diameter a lot of different ways as well. But let's see how can we make that diameter. So if I take this corner of that triangle to this corner of the triangle, so that will actually split the whole figure into two identical figures. So which we can count it. So like we have one arc, two arc, three arcs that is like outside of the rectangles. We have 1, 2, and 3. And then we have one part of the kind of sector, like the arc of this triangle, and 2 and 3, the same thing right here, 1, 2, 3. So which is why this might be our diameter, okay? So which is 8 units. So also, if I want to kind of connect this guy somehow with another way, maybe I can try to make a right triangle, because when you have a right triangle, when you have a diameter, and then if there's an angle that facing to that diameter on the circumference, that should be 90 degrees. So which is why it looks like this angle right here, this one right here, is gonna actually face the diameter. So which we can make a reasoning soon. So if I connect this way, that segment should be just straight line from this corner to this corner. The reason why we can easily say that is, this is this is 90 degrees, right? So when you connect this to a segment, this is 90, that 90 should actually face the diameter. So that's the only way that will happen if this is actually going to touch this corner of this diameter. And that's kind of what we can say. Also, we know that, this is 120. So, and then this segment and this segments are equal, so which means 30 and 30. And if you remember some of the previous videos I made it, so when you have 30, 30, 120, this guy is x, which is we are told, and then this is x, this guy will be x root 3. And if you don't remember, you can always drop this altitude and make 30, 60 and get this immediately, but it is really common, so good to know. And then this segment is 1, and this segment is also 1, so which means this side is 2 plus x root 3, and this is 8, and this side is also x, so we can have another Pythagorean. So that will be x squared plus 2 plus x root 3 to the second power, and that's equal to the diameter square, which is 8 squared. And if you solve this equation, it's going to give us the same result as before, so I'm not going to do that now. but that will give us another solution. There are a couple other ways you can attempt. Even you can try like chord version with this problem, even though I probably don't do this in this problem, but that is also possible. So it was a cool problem in my opinion because it was like challenging problem, to be honest, number 22. But at the same time, the thing that we did to get the answer wasn't really that bad. So I hope that was clear. I'll see you next time.